So this is 2x plus 4 divided by x squared plus 2x plus 2. Okay, and so yeah, here this is already you know, this is already decomposed. This is already a simple fraction, right? Because the roots of this are going to be -2 plus -4 minus 8, right? So these are not real, so this doesn't have a root. This is already in the simplified form, right? So how do we deal with this? Well, as we have just seen, what we want is to express this as the sum of the logarithm and an arctangent, right? The first one, the logarithm, we need to get in the numerator the derivative of this, but the derivative of this is 2x plus 2, right? So we have 2x plus 2, right? Divided by x squared plus 2x plus 2 dx. So we can separate this into 2x plus 2 divided by x squared plus 2x plus 2 dx, right? And then now we have 2 times 1 over x squared plus 2x plus 2, right? Now the first one, we know this is going to be the logarithm of this thing. Now we have to deal with this. What is this going to be? X squared plus 2x plus 2. We know that this has to be the arctangent of something, okay? But the arctangent is going to be always something like 1 plus something squared, right? So we want to get a perfect square out of here, right? And then see what happens with the rest, right? But in this case it's easy, right? Because so in order to get a perfect square, what you do is you get the first two terms, right? X squared and x, and then if you have a perfect square here, you will have ax squared plus 2 times abx plus b squared, right? Now in this case a is 1, in this case, so you have a is 1, and then b is also 1, so this is equal to x squared plus 2x plus 1. This is equal to ax plus b squared, in this case x plus 1 squared, right? And then you just complete the square when you have with, you know, comparing with the original expression. So this is going to be 1 over 1 plus x plus 1 squared, right? Now in order to find the derivative, or sorry, the primitive of this in terms of the arctangent, this is easy to see that it's going to be the arctangent of x plus 1, right? But we need the derivative of x plus 1, right? But in this case, the derivative of x plus 1 is 1, so this is okay. This is going to be the arctangent of x plus 1, right? Plus the constant, okay? So going back here, so this is the logarithm of x squared plus 2x plus 2, and remember this is going to be positive always, so we don't need to write this in absolute value, and then we have plus 2 times the arctangent of 1 plus x plus c. Okay? And then let's do one final example. Next one is 2x plus 4 divided by x squared plus 2x plus 2 squared. Okay? So you could try and write this like ax plus b divided by x squared plus 2x plus 2, and then another fraction, right? cx plus d, x squared plus 2x plus 2 squared, right? This is the decomposition. But in this case, you can see that if you do that, you have this is equal to this, right? So 2 equals c and 4 equals d, and this is going to be 0. So this is already in its partial fraction form, right? Now we need to use the same trick as we did before. So this is going to be, remember, 2x plus 2 plus 2, or in other words, if you want 2x plus 1 plus 2. So this is going to be 2x plus 1 divided by, and then this, remember, it was x plus 1 squared plus 1, all of this squared, right? And then we have plus 2 times the primitive of this, x plus 1 squared plus 1 squared, right? Now this is easy, right? Because this is the primitive of this, right, to the minus 1. So this is minus 1 over 1 plus x plus 1 squared, right? Plus the plus a constant, right? Now the question is, what about this one, right? So we have we need to use the recurrence x plus 1 squared plus 1 squared, right? The recurrence that we found in our previous video, okay? And if you remember it, it was I sub n, sorry, let me write it here. This integral, which was the integral of dx 1 plus x squared to the n. Okay, so in this case we have this with x plus 1 squared, but this is the same to the n, right? And in the previous video we obtained a formula for I2, which is with this squared. So this is a half of the arctangent of x plus 1/2 of x divided by 1 plus x squared, right? So you can substitute here it and multiply by 2. So this is the arctangent. In this formula it was x, this is x plus 1, so this is the arctangent of x plus 1 plus, and then we have x plus 1 divided by 1 plus x plus 1 squared, okay, plus c. So this is this formula, right? You cannot actually see how this and this cancel out, right? So you have this minus 1 and this 1 go away. So the formula, this primitive, it's going to be this, the arctangent of x plus 1 plus x divided by 1 plus x plus 1 squared plus